In this video, I am going to share with you very important points about X-rays. That is, what are properties of X-rays, how are they produced, what is meant by X-ray spectrum, what is the effect of voltage on spectrum of X-rays, how these X-rays are produced, what is the mechanism of X-ray spectrum, what is meant by fine structure of X-ray spectrum, what is MOSLEY law, what is Auger effect. First of all, let us come to what is meant by X-rays. X-rays are nothing but beams of photons of energy ranging from 0.1 keV to 10 keV. Now let us come to various important properties of X-rays. Wavelength of X-rays lies in the range of 10⁻⁻5 to 100 angstrom. If wavelength is below 1 angstrom, the X-rays are called soft X-rays. If wavelength of X-rays is above 1 angstrom, then these are called hard X-rays. X-rays always travel in a straight line with the velocity of light. When X-rays pass through any matter for a long time, then heat is produced. X-rays are electrically neutral, so these cannot be affected by electric or magnetic field. X-rays can't penetrate bones due to high density. X-rays can cause fluorescence when they are made incident on some special materials like zinc sulfide. A photoelectric plate is very strongly affected by X-rays. X-rays have very high ionizing power. Emission of electrons takes place from surface of metals when X-rays are made incident on them. X-rays can cause chemical and biological effects in human body if exposed for a long time. Now let us come to the point how these so popular X-rays can be produced. What apparatus is used for this? The most modern apparatus used for production of X-rays was discovered by Röntgen in 1895, and this apparatus is known as Coolidge tube. This tube was designed by a scientist Coolidge in 1913. What is a Coolidge tube? A Coolidge tube is a highly evacuated glass tube having a filament. A copper tube is fitted in front of the filament and water is made to circulate through it for cooling purpose. A target made of a metal having high melting point like tungsten or molybdenum is properly mounted on the copper tube as shown in diagram. The beams of electrons produced by filament are accelerated to a very high energy under high potential difference and are then made to strike the target that acts as anode. After penetrating the target, these electrons come to rest. About 99.8% of electrons energy is converted into heat and only 0.2% of incident electrons appears in the form of X-rays. The intensity of emitted X-rays depends on number of electrons falling on the target. The energy of emitted X-rays depends on velocity of the electrons. Now, next point is what is meant by X-ray spectrum. It is nothing but a graphical representation of variation of intensity of X-rays with their wavelength. Intensity of X-rays plotted along y-axis against wavelength of X-rays along x-axis. The area under the graph gives total energy emitted in the form of X-rays. The peaks in this graph constitute the so-called characteristic spectrum, and the remaining portion of the graph is called continuous spectrum. The minimum wavelength of produced X-rays is called cutoff wavelength, represented by lambda with subscript minimum, and lambda minimum is independent of nature of the material of target. Now let us see what is the effect of voltage on spectrum of X-rays. The graph shows that the value of cutoff wavelength becomes smaller with increase in accelerating voltage. The wavelength corresponding to peak value of intensity decreases with increase in accelerating voltage. The intensity of X-rays corresponding to any wavelength decreases with increase in accelerating voltage. Also, it is clear from this graph that with the rise in accelerating voltage, total energy emitted in the form of X-rays increases because area under the graph goes on increasing. Now let us come to mechanism of characteristic part of X-ray spectra. The peaks constituting the characteristic spectrum represent the wavelengths corresponding to sudden rise in intensity, and these are the characteristic of material of the target that is used in experimental setup. Let us suppose the energy of some emitted X-ray photons is sufficient to eject out the innermost k orbital electron from an atom of the target. The vacancy so created may be filled by an electron from some higher orbit. If the orbital electron is shifting from L shell to K shell, then the energy emitted is E alpha equal to EL minus EK. When the electron shifts from M shell to K shell, then energy of X-ray photon will be EM minus EK, and so on. The X-rays corresponding to energy E alpha, E beta and E gamma are specially named as K alpha rays, K beta rays, K gamma rays respectively. All these types of X-rays are collectively known as K series of X-rays. In the same way, we can obtain L series of X-rays and M series of X-rays as shown in figure. One more important point regarding X-ray spectrum is what is meant by fine structure of X-ray spectrum. It is the existence of K alpha, K beta, K gamma X-rays in K series. Similarly, L series also has fine structure, M series also has fine structure. What is meant by MOSLEY law? MOSLEY law states that frequency of any X-ray spectral line is directly proportional to square of the atomic number of target element that is used in the production of X-rays. What is meant by Auger effect? As we know, in case of photoelectric effect, each incident photon produces one electron. That is, the number of electrons emitted from surface of a metal is equal to number of incident photons in case of photoelectric effect. But in Auger effect, the incident photons of X-rays and the number of emitted electrons is different. That is, one incident X-ray photon produces more than one electron from surface of the metal. These extra emitted electrons are called Auger electrons, and this phenomena is known as Auger effect. Why this happens? It is due to the fact that the X-ray photon may have sufficiently high energy to knock out an electron from inner orbit of target atom. Then an electron from some higher orbit may fill up the created vacancy, resulting into the emission of a new photon of energy. This newly created photon may have sufficient energy to emit out another orbital electron. This process may repeat and give rise to more and more electrons. This is the mechanism of Auger effect. Thanks a lot. I expect comments from the viewers and I will try to respond to those comments also.